In this video, I wanted to show you how to integrate with respect to y using the TI-84 calculator. Now, there's actually going to be multiple ways to do this, so we'll do this in a couple of ideas. So obviously, we're dealing with definite integrals on the TI-84. We want to calculate definite integrals using any variable, not just x, but we can use y, we can use whatever letter we choose as our variable. Now, we've already done some integration with respect to x. So just to remind you, let's say we want to find the value of this definite integral. Pi times the integration from 0 to 2, and we are integrating the quantity 4 minus x squared, quantity squared, with respect to x. So what I would have done is I would have gone into the math menu on the TI-84, and then I would have gone down to FNINT. Since I have the math print on, it'll actually look like an integration. So I'm going to integrate from 0 to 2, 4 minus x squared, quantity squared, and with respect to x. So every time I want an x, I'm hitting the variable key x, which is right here. Now, I could have done that. That's 17 and 1/15. I could have also put the pi out front. So now I could just do a multiply my answer times pi. Again, to get the answer, I'm hitting second and then the negative key. If I wanted to, I could have done that all the same, but just had a pi out front by just using the pi button. Again, that's second and this caret button out front. So that's how I would have done that integration using the TI-84 plus calculator. If you don't have math print on your TI-84, if you're running the classic system, then it's a little bit different, but we've already done that in a previous video, so you can check that out if you'd like. So let's take a look at another example. And this one is where we integrate with respect to y. This was an example calculating volume using the disk method. Pi, integrate from 0 to 4, the square root of 4 minus y, quantity squared. If you want to simplify this, you can. I'm going to leave it in to prove a point. So if I want to utilize y as my integration, there's really two different ways I can do this if I want to integrate with respect to y. The first way is the way I use most often. And I say, well, it actually doesn't matter what variable we used, as long as we're consistent. There's a y as my variable inside, y is the outside. So if I wanted to put a w in there, I could have put a w. Or if I wanted to put the variable p in there, I could have put the variable p in there. And all of these integrations would be the exact same, just using a different letter. So the easy way to do this is to say, well, that would be the same if my variable would have been x. And so if my variable is x, then I just turn to the calculator and I put this in using variable x. So once again, I would go into the math menu. Actually, math 9. We're integrating from 0 to 4, and then it is the square root of 4 minus y. But instead of the y, I just put a variable x, quantity squared. And then again, instead of integrating with respect to y, I'm integrating with respect to x. That gives me an 8. And that's basically all we need to do. I can multiply times pi at the end because my integration had a pi out front. The other thing I could have done is I could have started my integration by just inserting a pi out in the front. So that is one option for integration. So we just integrate, and instead of using the variable y, we just replace all the y's in my integration with the variable x. Now, the other option to do this, if you don't like replacing y's with x's, is we can actually do the same integration, but we can actually put the letter y in there if we like. So we're going to take the square root of 4 minus y. In order to get a y, I just have to hit the alpha and then the number 1. That'll give me the y value. So 4 minus y, quantity squared, 4 minus y underneath the square root, quantity squared with respect to y. And again, I'm making sure I hit the alpha and then number 1 to get y. And if I hit it that way, you see that we get the exact same answer as well. So again, the two methods that I use, usually I just replace all the y's with the variable x. The other method you can use, if you don't like that, if you're getting confused with x's versus y's, is just hit alpha y and let that be your variable. By the way, it doesn't matter that this was an x. If your mode was in parametric, then when you hit this key, you'd be integrating with respect to t. If it was in polar, you'd be integrating with respect to theta. So if you do find yourself in another mode, whether it's parametric or polar or the function mode, you can do that as well. So in parametric, when I hit this variable, I get a t. And it's all the same, obviously. Again, I'm just using a different letter. So whichever way you want to do that is perfectly fine. I'll be in function mode. That's the one I'm most familiar with. So any letters you want, come up with the same answer. And again, I typically use either Y's or X's, and I found the answer. Again, that answer was approximately 25.13, which is 8 pi. Let's do another example. This is an example from fluid force. 62.4 out front times the integration from -7 to 0 of 3 minus y in parentheses, all in parentheses, times -4/7 y integrated with respect to y. If I wanted to do this on my calculator, again, there's two options for it. So we'll go with both options. I will go 62.4 and then integrate from -7 to 0, 3 minus y. This time I'm going to use the variable key. Make sure the 3 minus that variable is in parentheses times -4/7 y. Again, that -4/7 needs to multiply times both terms if I had that. If I was doing this by hand, I would multiply both terms. And integrate with respect to y. I get 6,697.6. If you don't like that, if you'd rather integrate with respect to y and have it look like a y on your calculator, then you can go 3 minus, again, alpha, the number 1, gives you the letter y, multiplied times -4/7 alpha, then the number 1 gives you a y, and then integrated, whoops, make sure you integrate with respect to y if all of this is with respect to y. If I say integrate with respect to x, this will give me a problem. It'll give me a not the right answer, right? Because we're integrating with respect to x. You end up getting some weird number here because y is probably stored in a certain way on your calculator. So make sure when you do this, you integrate with respect to y if your variable is done with respect to y. But regardless of which option you use, either the first or the second, you'll get the same answer. Again, just don't mix and match your variables like we have on the second line. That can really throw things off. So that's not a good one, but either of those is. Again, that middle line we had stored must have been some value stored for y in my calculator somehow, or y as a variable. So either or will work out just fine. And that's how you could do that. So that's how to integrate with respect to y. And obviously, once you know that, now you can integrate with respect to w. You can integrate with respect to the letter p, with respect to t, with respect to theta, with respect to any other variable that you want.